Now this is the next question. We are given f of x is equal to integral root of x over 1 positive x whole square times dx. We expected to find f of 3 negative f of 1. So foremost, let me consider the given question. F of x is equal to integral root of x over 1 positive x whole square times dx. I'm going to take x to be equal to, say, tan square t. I differentiate, I get 2 times tan t times differential of tan t is secant square t times dt. So this is equal to, in place of x you substitute tan square t divided by 1 plus x is going to be tan square t, and that is raised to the power of 2 times dx is 2 times tan t times secant square t times dt. So this square root will reduce the degree to 1. So you have tan t, you have a tan t, so it's going to be tan square t times secant square t times dt. Now secant squared x negative tan squared x is equal to 1. So that means secant squared x is equal to 1 positive tan squared x. So you substitute that here. So you will have secant raised to the power of, is actually a 2 there, but there is also a 2 there. That's going to be 4 there. So since we're dealing with t, you substitute t there. So you have to integrate, but there is a 2 there, you place the 2 outside. So secant squared and secant squared goes up. So you have a tan squared. Tan squared, I'm going to write it as sine squared t divided by cos squared t. There is secant squared t. Flips, you get cos squared t times dt. So cos squared and cos squared goes up. You have 2 times of sine squared t times dt. Now 1 positive cos 2x divided by 2 is cos squared x, and 1 negative cos 2x divided by 2 is equal to sine squared x. So utilizing this formula, this is going to be 2 times integral. In place of sine, I'm going to have 1 minus cos 2t times dt. You integrate this, you perform the integration. This is this will lead you, actually the 2 goes off because 2 times sine squared t, right? So we don't have to place this 2. So this 2 goes off. We don't need this 2. So integrating 1 of 1 times dt would give me a t there. Integrating cos 2t would give me a sin 2t divided by 2. Now you will have to do some adjustments because you have a sin 2t here. Now what I'm going to do is I'm going to rewrite this as t negative sin 2t divided by 2. I can rewrite this as tan t over 1 positive tan square t. Now you may be asking me, how do you do this? Now watch here, tan t is nothing but sin t divided by cos t. Now 1 positive tan squared x is nothing but secant squared t. So you substitute the secant squared t. Now you have a sin t over cos t. Secant squared t is 1 over cos squared t. So you take it to the numerator. So you have a cos squared t there. Okay. So now what happens here? A cos and a cos gets cancelled, giving me sin t cos t. Give me what? Sin t cos t. So actually what I should do is I would have to get that sin t cos t over here. Now that is simple. Why is that simple? Watch here. Sin 2t divided by 2 is nothing but 2 times sin t cos t. Right, there's a 2 there. So 2 goes off. So actually what are you left with? You're left with sin t cos t. So that's why in place of sin t cos t, I'm going to utilize this equivalence. So t negative tan t over 1 positive tan square t, positive arbitrary constancy. Fair enough. Now what exactly did we make the substitution as? See, substitution is x is equal to tan square t. X is equal to tan square t means, I'm going to show you, it means root of x is equal to tan t. So that means t is equal to tan inverse of root of x. So that is the deduction we have. So go and substitute that. So in place of t, you have tan inverse of root of x. Now x is equal to tan square t. So that means tan t is equal to root of x. So you have a root of x there. X is equal to tan square t. I hope you are watching it. X is equal to tan square t. So this is one positive root of x. Okay. Positive arbitrary constant. See, this is going to be my f of x. Okay. Now we will have to use the boundary conditions. So let's do that. So at x is equal to 3, f of 3. So substitute x is equal to 3. So it's going to be f of 3 is equal to tan inverse of root 3 negative. This is root 3 divided by 1 positive. This is actually, it's not root of x here, this is just x. Because x is equal to tan square t. You see the formula? X is equal to tan square t. So this is going to be 3 added with c. So this is my f of 3. So let me go to the next page. Now I need to get f of 1. And x is equal to 1. So what is f of 1? F of 1 is equal to tan inverse of 1 negative root of 1. X is equal to 1 divided by 1 positive c. So this is f of 1 is equal to tan inverse of 1 negative 1 over 2 positive c. So this is for f of 3 and this is for f of 1. So we need to find f of 3 minus f of 1. Right. Now this can be actually, we know the value of tan inverse of root 3, right? Now tan inverse of root 3 will produce as a value of pi over 3. Am I right? So we can actually utilize that value, pi over 3. So therefore, let me bring this step. So f of 3 minus f of 1 is equal to tan inverse of root 3 negative root 3 over 4 positive c negative tan inverse of 1 negative 1 over 2 positive c. Now this is going to be tan inverse of root of 3 negative tan inverse of 1 and negative root of 3 over 4 positive c negative positive 1 over 2 and negative c. So positive negative goes up. So you have tan inverse of root of 3 negative tan inverse of 1 and you can actually perform some simplification with this. So you have 1 over 2 negative root of 3 over 4. I take the LCM as 4. You get 2 negative root of 3. Right. If you want, you can just place it as it is. So what I'm going to do is I will just place it as 1 over 2 negative root 3 over 4 because it doesn't look good, this one. And as far as this is going to be pi over 3. Now tan inverse of 1, right? So we can take the tan inverse of 1, that's going to be 45, that's pi over 4. So pi over 4 positive 1 over 2 negative root 3 over 4. So you take the LCM for this, is going to be 4 pi negative 3 pi followed by 1 over 2 negative root of 3 over 4. So this will give you pi over 12 positive 1 over 2 negative root 3 over 4. What is this? This is nothing but f of 3 negative f of 4. Okay, so that's a solution. Anyway, I have done it extensively, that is to show people the scaffolding, right? So that is the solution to this question. Thank you.